Hey guys, this is lesson 13 for day one of lesson 13. And in this lesson, we will do a thinking experiment, online simulation activities one and two, and watch a video of some marble simulations. Okay, so our thinking experiment. So think about the following scenario and answer the three questions that follow. We added room temperature water to a cup and surrounded it with cold water. The cold water outside the cup warmed up, and the room temperature water inside the cup cooled down. All right, our second task, online simulations number one and number two. So, in activity one, we're going to answer the question, what changes did you notice happening in the motion of the highlighted particle? And in activity two, we'll answer the question, what do you notice about the motion of particles in a collision? So let's do simulation number one. We are answering the question, what changes did you notice happening in the motion of the highlighted particle? So as we watch this simulation, think about how you would answer that question. What changes did you notice happening in the motion of the highlighted particle? Okay. So this circled particle here, this is our highlighted particle. Keep your eye on the circled particle. And remember, think about what changes you notice happening in the motion of the highlighted particle. Okay, please answer the question. Okay. For the second question, what do you notice about the motion of the particles in a collision? So I know it will be difficult to follow as many particles as we did in the last one. So I will reduce the number of particles in the simulation this time. So this time you're not only going to be watching the highlighted particle, but you're also going to be watching the other particles involved in the collision and what changes do they have. So there's our highlighted particle to follow. So not only are you watching this particle, but you're going to also watch to see what changes any particles that collide with it, or collide means to crash into it, bump into it. What changes do they go through as well? Okay, let's answer question number two. So exploring speed. When the speed of one particle decreased in the collision, what happened to the speed of the other particle that collided with it? So, if the speed of one particle, once they collided, one was going faster, it decreased, it slowed down. What happened to the speed of the other particle that collided with it? We'll see if we can't get that to cooperate with us. So let's do So this time you're going to watch for if this particle collides with another particle and it slows down, watch the other particle that bounces off of it. Does it slow down or does it speed up? Or does it stay the same? So there it decreased. What happened to the particle here? So it slowed down, now it's sped back up. Okay. So when the particle decreased in its collision, what happened to the speed of the other particle it collided with? And then what is the opposite? If that particle increased in a collision, what happened to the speed of the other particle it collided with? The marble simulation. So, task number 3. We've been considering 3 different states of matter in our unit whenever we can. So, for things like solids, like the walls of the lids and the cups, or the table that it's sitting on, we have thought about solids. We have liquids in this system, like the drinks in the cups, and gases, like the air above and around the cup. The term state of matter is just a way to refer to whether something is a solid, a liquid, or a gas. So, marble simulation, let's see if the same sort of thing happens when we use marbles in place of these simulated particles. So, we watched simulated particles, little computer generated dots. This time, we're going to use marbles in place of the dots instead. So, as we watch this video, observe how the collision affects the speed of both marbles. Be prepared to answer the following questions. I will show the video twice. What did the particles in the computer simulated activity and the marbles in this video best represent? Do they represent a solid, a liquid, or a gas? And then what interactions did we see between the particles that resulted in a speed change? Here's the first playing of the video. Okay. Here is the second playing. Remember, we are looking for the answers to these 2 questions here. So how does this idea of these marbles and the computer simulation, how do these ideas connect to our cup system? Particles in a cup system are moving around freely and colliding with each other. This causes changes in the particle's speed. Collisions between particles in a gas can transfer kinetic energy. Sometimes we can write that as KE for kinetic energy, or sometimes we refer to that as motion energy. So the collision between these particles in a gas can transfer kinetic energy from one particle to another. So let's see if energy transfer occurs between particles of a gas and a liquid. We will put a group of marbles closer together to represent a liquid, since particles in a liquid are closely lumped together but can still move freely past each other. Again, I'll play this video twice. As I play the video, think about and be prepared to answer the following questions. What state or states of matter is this closely related to? And what interactions did we see between the particles that resulted in a speed change? Okay, here's the second plane. Okay, we are still missing observations for one state of matter. We haven't looked at whether energy transfer can occur in particles of solids. So, in this video, we use magnetic marbles to represent a solid because they will stay in place. And we know that particles in solids don't move around about freely like particles in a liquid or in a gas. So as I play this video, and I'll only play it once this time, but you're only looking for one thing. So as I play the video, observe how the collision affects the motion and speed of all of the glass marbles in the system. So those are the marbles here inside, these colorful marbles. Be prepared to share what you noticed. Okay. So I will play the video again, but this time you're looking closely for evidence in any changes in the motion of the magnetic marbles. So those are the marbles here along the outside. So focus in on those marbles and see what if there's any changes in their motion during the collision too. Be prepared to share what you notice. Okay, guys, so that is the end of lesson 13 for day one. Be sure to go back to Google Classroom to click the Turn In button. That way, it alerts that your science teacher that you have completed this Ed puzzle and you are ready for her to grade it.